just waiting for a couple more people to arrive. What we're going to do is have a discussion about design solutions for overheating in schools. And we're just going to have a short presentation from Namazi Yazaman when she arrives. Unfortunately, she was at the other meeting. What I could do to start with is just put the slide up that Tim Taylor ended with in the last meeting, and I'll just share that for a second, which gives a sort of overview of the measures that he had listed. And so that's probably a good place to start. So this was the slide which Tim came up with. Are you here, Tim? Are you on this call?
Yes, Richard, I
Do you want to
dialed in a bit late.
Talk us through your slide. Can you see that slide?
Yes, yeah, that's fine. It's come up on the screen. Essentially, it was a kind of list which I had pulled together, I think, with reference to some other publications as well, and as part of a presentation to a different group. And essentially, it's just a means of identifying the kind of range of measures you might consider for sort of controlling or sort of reducing the risk of overheating. It was, it's just a way of kind of structuring the things that you might consider as part of that process. Some of it relates to it follows the kind of principles in a similar way to the energy hierarchy. You try to reduce the demand and then sort of try and provide a kind of comfort in a sort of efficient way. So, for example, reducing internal heat gains is thinking about how we reduce the amount of heat that's entering the space. Moving the excess heat and the sort of reducing the operating temperature. Some of those are sort of more passive measures, others are more active. And then there are some things which perhaps blur the boundaries a little bit between the sort of the internal and external environment. So it's just really to give a structure about the types of measures that you might consider. I think based upon the previous call that we had, I think some of these things are sort of fairly well kind of understood and already implemented or have been sort of looked at in the past, whereas other measures, for example, ceiling fans was something which I think we felt it would be useful to gather a bit more sort of data on and sort of get some kind of real experience of people's people have implemented these types of solutions in buildings.
Great stuff. So Yazaman's here now, so maybe we can have Yazaman's update. So Yazaman gave us a talk last time about some of the research he's doing on 4 schools using the NVMet external modelling, and I think she's now got through some more of the simulation. So if we give Yazaman like 15 minutes to update us on that, and then if you get your points ready, we'll open it to the floor and people can say what you think we should be doing to improve the situation with regards to overheating in schools. Yazaman, are you ready to present?
Yes, yes, thank you.
Great stuff.
I will. So the screen is shared, right? That's.
Can see.
Yes, that's correct.
Yeah. Okay. So the title of the project so far is The Impact of Green Infrastructure on Thermal Conditions in Schools During Summer, which is a PhD project. And previously I shared that the aim is exploring the influence of green infrastructure on indoor and outdoor thermal conditions in schools, and the phases of the study after literature review was field study and simulations on 4 schools. The schools were located in areas with different socio-environmental characteristics, for example, the deprivation or tree canopy cover. And 4 schools were selected that were all in Coventry. And measurements were carried out last summer in indoor and outdoor of these 4 schools, well, 2 sensors, one located in tree shaded area and one in sunlit area, that measured air temperature, globe temperature, wind speed, relative humidity, and also a thermal camera for surface temperatures, and indoor sensors for air temperature and relative humidity. And also some calculations were made on how much is the coverage of each material in the school, because well, I took thermal images to show how hot or cold some materials were, so I needed to calculate what was the coverage of those hot or cold materials. And one update is that I also calculated urban greening factor for those schools based on what's being provided by, I think we should say, Mayor of London. The calculation tables and everything were provided. So I calculated UGF for the 4 schools, and it was between 0.25 to 0.6, which means 3 of them had the minimum of 0.4, but also this UGF was aligned with the socio-environmental factors as well. So, and then the results of this part is now published in journals, so you can find the comprehensive results and everything, including the UGF. And well, some of the results were shared last time, for example, that warm classrooms were recognized and with potential reasons, and also the cooling effect of tree shade, which was up to 6.4 degrees on outdoor air temperature and more than 22 degrees on mean radiant temperature. And also the results of surface temperature of materials is published in the paper. But the new thing about urban greening factor was that when I compared it to air temperature, firstly, it didn't really have any correlation with outdoor air temperature because, well, outdoor air temperature can be really variant from one point to another. So if we want to compare urban greening factor with outdoor measurements, maybe it's better to have a lot of measurement points, which is usually impossible because of the limitation of sensors and everything. But it had a higher, a stronger correlation with the average indoor or average classroom temperature. But at the same time, because urban greening factor was aligned with other socio-environmental factors of the areas that the schools were located in, so we can't say for sure which factor was exactly effective. That, for example, higher UGF had lower indoor temperature, or was it because of the tree canopy of the whole area? But one problem also with urban greening factor was that, as you can see in this picture on the right, that a school can have, for example, 0.6 or 0.5 UGF with a lot of trees, but most of the trees can be concentrated or all just located in 1 or 2 locations in the schools, while a huge area of the school is not covered with tree canopies and does not have enough shade. And this coverage is not really included in urban greening factor. So if we want to use urban greening factor as a factor that can be responsible for air temperature, it might need some more development. And for simulations that I am now working on, I realized that I can also, well, the cooling strategies that I'm working on are replacing or covering the areas with hot materials, which were, for example, artificial grass or asphalt, because replacing might not always be a good or something that the schools can really do. So maybe covering is easier for them. And also having trees not only in the schools, but also in areas outside of the school to have a higher impact in the whole area. And also seeing the age of the tree, which was something not really possible with previous models, but now I can see the impact of young or medium or old trees of the same species of trees. For example, a maple tree, which is young or old or medium. And green roof and green wall, especially green roof, is going to be tested not only in the school but also in the surrounding area to see again the higher impact of it. And the proper locations for trees will be also considered because, as I said, one school can have a lot of trees, but all just located in one spot. So maybe just adding a few more trees in some more strategic locations can provide enough shade both for the outside area and also on the building, on warm classrooms that might have very hot outdoor, like very hot facade. So trees that are specifically shading those classrooms might have enough cooling effect for us. And the results of these simulations will be used as microclimate weather file for our building simulations instead of using the weather files that are just provided for each city. I'm going to have my own weather file for each building simulation to see these strategies, how these strategies work for classrooms air temperature. And this is the, for example, map of the school and its surrounding area, which is used as a bitmap file in the NVMet model. And the expected outcome will be, again, as I said, the locations of trees. So if we don't want a lot of trees, if we just can have a few trees, what are the optimized locations for them? And also for outdoor activities, maybe in some schools, the playgrounds should be moved to a cooler area, for example, from south to the north. And the role of urban greening, if it gets better or even worse, how can this affect schools' air temperature? And one more important thing is that the combination of these strategies, how would it work? Because sometimes we recognize the best strategies, but the combination of them is not going to be that better. So maybe just one or two strategies combined together will be enough for us. And also the new for new schools, I'd like to know how I can design outdoor like playing grounds, because we cannot change a lot of things about the existing schools, but for future designs maybe it's better to have some better strategies. And that's all. I'd like to hear any question, but also ideas, opinions of how to make this better.
Thanks.
Thank
That gives
you.
us a good overview actually of some of the possibilities. Anybody got any questions to start off with, or should we have comments? Alan seems to have his hand up. Alan.
Yeah, one of the things that we've looked at is orientation, and one of the best orientations for a school is the east facade. The one limitation that it has is that the sun can get onto it quite early in the morning time and be on it for quite a number of hours before people get into it. So planting trees on an eastern facade keeps that low angle sun off the facade, and effectively has only 2 hours of occupancy so that the amount of exposure it's getting is significantly lower, and also the actual temperature in the morning time is lowest as well. So your east facade has the potential of performing the best, but it needs some additional protection. So trees certainly can help out with that. And the other aspect, obviously, is the kind of biophilic response that people would have. So if they're looking out at trees, then it tends to make them more tolerant of thermal discomfort. So they just aren't as susceptible to it. And in terms of kind of just generally landscaping, not necessarily trees, but keeping the hard standing away from the edge of a school, typically we found that the first 10 meters is the most critical. That's what has the greatest impact on the overheating within the classrooms themselves.
Excuse me, first 10 meters of around the building, you mean?
Yes.
Yeah, okay, thank you. Yes, thank you. Thank you so much.
Sorry, I was on mute. I think that's quite a design challenge, Alan. Because
It is,
I've never
yeah.
seen a school with a 10-meter strip around it, but it needs thinking about, doesn't it, architecturally? I know Megan, our landscape architect, is not on this call actually, but she's been advocating rain gardens up against the facade, which might go some way to make that a lesser distance than 10 meters.
Yeah. It's just really just
excuse me. Well, it doesn't necessarily need to be trees, as Alan said. Well, hopefully I can, in this simulation, see the effect of tree or any greenery on the facade, like radiation, like heat flux and everything. So I don't necessarily need to put trees and shade, maybe just hedges, or even the green wall might help somewhat. So that's also a thing. But still, if we talk about like surface material, unfortunately, there's a lot of asphalt which could be like easily changed to something less warm if we consider that 10 meter, which is very important. At least we could say no more asphalt in that 10 meter around the school.
Yeah, we've seen some schools that have had problems trying to purge themselves at nighttime because the asphalt has absorbed so much heat that the temperature going into the class in the evening time is maybe 3 degrees higher than ambient.
Yeah, that's what I also measured, that, yeah, in the morning or like some hours still the temperature is high in classrooms, also because there's no nighttime cooling. But yeah, that's not really expected, that when outside was a lot cool, indoor was still very warm. So hopefully I can make that better.
Anyone else want to come in?
Yes, please.
Yes. Go ahead, Malcolm.
Yeah. First of all, thank you for the presentation. That's a really interesting and helpful study you've carried out, and probably carrying out more on it. I had a few sort of questions and a couple of comments actually. It won't take too long. The first of which, when you're calculating urban greening factor, is that for the school site only, or is that for the wider locality?
Urban greening factor.
Yeah.
Yeah, well, urban greening factor has to be just for the site, as being explained, that each building should have its own urban greening factor inside the boundaries of the site and not outside.
Yeah, okay. The reason I asked that is I'll just make a comment. when you're sort of looking at the benefits of sort of urban greening, green infrastructure and so on, you typically get it from quite large areas that go much larger than an individual site, sort of hectares we're talking about, of sort of changing asphalt to sort of trees and grass and so on and other plants. So while the measures you're doing on the site will have some benefits, in terms of sort of directly affecting, like, for example, the air temperature, you do need large areas. So my question, I guess an observation would be, you might also want to look at what your sort of your local urban green factor is that extends beyond the school itself, and see how that sort of interacts. Because the other thing you see, if you have wind blowing in a certain direction and there's nothing, it's just sort of concrete and asphalt in the in between sort of the fetch of the wind and your building, it's never going to, the air is never going to experience anything on the site if it's coming from that direction, if there's nothing there. So I think it's really important that you sort of think a bit wider as well. I think you need to do both. You need to look at the local site, because you know this, what's within the school, or this, the school's control is just within the site, isn't it? But in terms of climate change adaptation at local authority level, the sort of benefits have to go to much larger areas than single buildings. I think that's something that's become clear. And also, I had a question: are you taking into account evapotranspiration? Was it the package you use, EnviMet?
Yes.
Is that built into that?
Yes.
Yeah,
it does see evapotranspiration. Yes.
Yeah, because of course that's another way you can sort of get benefits of air temperature, and also an observation that by definition things that are green are absorbing everything else except the green light, so they actually absorb a lot of radiation. Now, that what happens then, of course, is complicated because it depends on the sort of the physiology of the plant and what it does with that radiation that's absorbed. So it's not the same situation where you're doing like sort of cool roofs. I think like in the US, for example, where they're trying out in other countries, they're trying these white roofs with special materials that are highly reflective, so they never absorb the radiation in the first place. Then the question is where that reflected radiation ends up, because if it gets reflected around the site or something, maybe of no benefit, net benefit. If it's on a flat roof pointing upwards, but so you don't necessarily expect to see some, how do we say, the effect on air temperature is complicated, I guess, would be my understanding. Please correct me if you think I'm wrong about these things, but that's you've got to look at larger scales than just the building site, but also the physics of what goes on is really highly complicated when it's sort of green plants and trees and so on as part of the mix. Now, direct shade in the building, of course, with trees put into the right place is completely valid and is straightforward to model. We can contrive something in RES or TAS or something to approximate that quite easily. When you're going beyond that to look at trying to convert between like a standard weather tape, CIBSE weather files, and what you're measuring locally, just be a bit careful, because within like the building simulation software, it will be the starting point will be, it's, for example, picking up wind speed at a 10-meter height, because that's what the meteorologists measure it at. And if you're measuring locally at a different height, you'll get, the software already has conversion factors to take account of that. The wind pressure coefficients on the building in the software will already take account of the fact that the meteorological data was measured at 10 meters and will make an adjustment. So I think you need some sort of caution about how you convert your locally measured data. I think it's possible to do, but you just need to sort of be aware of exactly what is routinely reported in the weather files. So I've spoken for a long time on that. That was all I was going to say.
Yeah, that's right. The simulations might not exactly see some of the things you said because I make a weather file that is like an average of around the school, and I just give it to the school. But before that, I will also see the outside, like the cluster, if I want to say the facade, in NVMet. So just to see how the heat just goes. I can see that, but separately from inside the school. So it could be nice. It could be like ideal if a software can do both in just one program. But when we do the APW file, it will become like an average. So, for example, if a tree has shade on one window, I can't see its effect behind that window.
Within NVMet, you
Yeah,
mean?
yeah,
Or,
NVMet is just for the microclimate, and I will get
yeah.
the APW file from it for my other software, which will be probably IS or Design Builder. So
Yeah.
because these two are separate from each other, that's the
Yeah.
problem. And yes,
I think
for now.
my comment there relates to sort of hidden conversions within a building simulation software package that you just need to be aware of. Just to point out, I'm involved in updating CIBSE Applications Manual 11 on building performance modeling. I was lead author for the 2015 edition, and we were just starting to update that. So if you have anything that you think is perhaps going into the modeling too much for a sort of a general design guide, then you might contact me and see if it fits within the AM11 update that we're just about to start working on.
Okay, thank you.
Yeah.
Sure.
So but what you're doing is really interesting. Thank you. Yeah.
Thank you.
Yeah.
Any other questions?
Yes, thanks very much for the presentation, Yazaman. It was interesting to see kind of some of the measurements you've taken at those sites, and that's it's always kind of good to see that sort of kind of calibration with real data. It was perhaps not so much a question, but a couple of observations. I think Malcolm had said that the research indicates that you need to be considering urban greening at sort of larger scales to see sort of a sort of a sort of an impact on the sort of the sort of wider microclimate, however we might define that. And I don't know if you've to what extent you've kind of been covering some of this research in your literature review, but I do certainly recall meeting some researchers from Brazil, and I can't quite remember if it was from Sao Paulo or Rio. It was a few years ago at a conference, who were sort of using MVMet to essentially look at that kind of question. Kind of what size of water body. Kind of how can you relate that to the sort of the impact on the sort of microclimate modification? So that this, I do recall that their research was highlighting that very point, that you needed fairly significant areas of kind of blue or green spaces to actually sort of modify the microclimate. We're talking very kind of local kind of microclimate modification, and maybe this, I think, is kind of where we're getting to. I think kind of intuitively we know that the kind of external microclimate sort of locally around a building is subject to a variety of things. The east may feel very differently from the west at certain times of day. And I think that the challenge that we have is that the sort of strategies we might want to consider for schools, for example, as Alan has mentioned, for example, tree planting, the sort of the benefit of other sort of green or blue elements within the landscaping, is that how we can account for that whilst perhaps not sort of either sort of overselling or underselling the sort of benefits of those strategies. So I think your research is great, because I think we do need to start to be able to quantify some of these things in a more rigorous way. But I don't quite. I mean, a colleague of mine did some research a number of years ago into how you can modify a sort of weather file for use in simulation tools. to take into consideration some of these microclimate modifications. But I think to be able to standardise an approach that could potentially be considered in a sort of a BB 101 overheating risk assessment is a sort of another step beyond. And I don't know if this is something you're necessarily having conversations with or your supervisory team to think about. The next step is, you know, how some of these approaches could be formalized in a sort of rigorous way that's kind of evidence-based, to be able to incorporate some of these sort of microclimate considerations in a way which we can have a bit more sort of confidence in terms of demonstrating the impact on overheating risk. I don't know if you're about to come back on that one, Malcolm.
Yeah, it was a question. Actually, is anyone here involved with the CIBSE Building Simulation Group? And then, if you are you looking at this issue that Tim just mentioned about converting from local microclimate measurements? Is the sort of thing they should be interested in if they're not? I suspect they are already, but I'm not involved with it, you see.
It hasn't come up yet.
Yeah, who's that? Sorry, I didn't see.
It's Kevin Bullen.
Oh, great. Yeah.
I'm on that committee as well.
Right. Yeah.
It hasn't been mentioned specifically, no.
Yeah.
But I can bring it up, certainly.
Yeah. I mean, my contact for AM11 is Darren Wolf. He's the lead author for the chapter I'm working on, or section I'm working on, as we're calling it. Can you mention to him might be the good starting point that if it's seen as something that's needed, you know, as consultancies and so on in universities, we can each come up with our own approach. But I think it's good if we can get consensus on that, you know, because if the local measurements are available, we want to take advantage of them. First of all, you have to probably have to have a protocol for what measurements you take and how you take those in the first place. And then having done that, you would come up, well, whether it's the simulation group or another group, would be able to advise on do the following things to take a standard CIBSE weather file and make it more specific to your site.
Yeah,
I think it would be really interesting thing and really useful, because it would help to sort of pin these things down better, wouldn't it?
Oh, I agree 100%. Yeah.
Yeah.
Sorry,
that's all. Yeah.
Come in.
Thank you very much for all of your comment. I think with relation to looking at beyond the context of a school, you're someone looking at the beyond context of a school by looking at the postcode because of the limitation of the PhD project, but she finds some relationship with the looking at the a wider kind of at the city level with relation to the heat urban island effect. Then she look at the urban green, just the UGF. So she look at both of them. So that's what I wanted to kind of emphasize, as she looked both of the kind of larger and just a smaller scale at the context of the school. But yes, you can explain more.
Yeah, there were some factors I could see by the district, if I want to say district size, like heat risk and tree canopy cover. These two were more important to me, and they are provided on in my paper, and also yeah, also population density and deprivation. But tree canopy cover and heat risk in the district were considered, the district that the school was located in. But when it comes to the school itself, I saw urban greening factor within the boundaries of a school. But again, with simulations that I'm adding more greenery, there will be a percentage, for example, before and after. For example, if it was 20% coverage and now I turned it to 40% coverage, and for the whole area outside of the school.
And one of the ultimate kind of aim of her PhD is to kind of coming up with a new weather file with relation to the urban green infrastructure. So if there is any way that she can kind of contribute to the updating the guideline, would be perfect.
Yeah, when I used weather station data or files that are provided by Met Office, it's just a lot of difference. So I can't really trust them for simulating the school. There's usually a few degrees, at least in the air temperature. So if I want to simulate a specific time and date, maybe it's better to use the modified weather files anyway.
Tim, do you want to come in?
Yeah, I think in the back of my mind, I also kind of wonder about the kind of application of these techniques and how they might be considered, you know, under a sort of what is essentially a sort of standard like BB 101. I mean, certainly, I think it would be useful to, you know, I think it'd be a positive thing to recognise the benefits of some of these microclimate modifications. But you know, I think it's that there are potential risks associated with them as well, which I think is worth considering. For example, maintenance of the sort of the landscape to ensure that those benefits are continue to be realised. Essentially, you know, and you know, for example, you know, trees, yeah, may become. You know, may not sort of necessarily be well maintained. They may die, and you may then lose those shading benefits. So I think they need to be, you know, it needs to be a sort of a means of considering these things in a sort of reasoned way that doesn't introduce kind of risks which can't subsequently be managed within the design. So I think that's probably something which, from a school's perspective, needs some careful consideration as well. So just to sort of consider that. I think partly also in the back of my mind, the question of modifying a weather file for the site-specific context. I mean, I think, you know, that feels like quite a complicated task. I'm not saying that things won't develop so that becomes more of a routine way of doing things, but I think there's probably some stepping stones on the way before we get to that point, you know, to be able to sort of do it in a sort of, you know, as a matter of common practice, because it feels like quite a complicated process to go through. You know, as you know, designers will be working with various other kind of other aspects in the design, and this specific kind of element relating to microclimate modification and sort of the use of green infrastructure, I think is a good thing, but I also think is probably quite a complex thing to model, and whether we are you know, whether there might be ways of simplifying some of the sort of evidence from research into ways that can be more simply transferred into either design guidance or be accounted for within certain sort of standards when we are thinking about good practice in design. So it's just, again, another observation, not so much a question, but yeah, I mean, I think perhaps the building simulation group may have some sort of useful input here to understand what the sort of future of this area might be.
There's a couple of comments in the chat. One from Edith Blenner has it. Perhaps rather than altering a weather file, there could be some form of factor multiplier adjustment to results based on local landscape. And then Richard Bowen has said, what about Athenaeum and weather shift weather files? And then Paul Vorster has said there would have to be strict guidelines for modifications to weather files to prevent intentional or unintentional misuse. All good points, I think. If anyone wants to come in on any of those, please do. Alex Melicha?
Melika. That's right. It's Polish, and so in my experience, so I've done modelling both for schools in Scotland and acted as a client who reads the results from, you know, all the studies that I see everyone does here and so on. I applaud more accuracy and sort of an ability to incorporate landscaping. I didn't even know that this was possible, so this is fascinating to see. This is my first school design sort of thing, so hello everyone. I would always caution about sort of, one of the great things about the CIBSE weather files is that they're consistent. And in my experience, a lot of problems we sometimes have is that people don't even use the up-to-date weather files, if you see what I mean, unless you kind of ask them to and say, stipulate it and so on, etc., etc. So getting consultants to modify them, I just suddenly go, I'm not suggesting intentional, I'm just suggesting unintentional stuff. It would be difficult to write a sort of a cohesive scope of works to say, you can do this, unless there was a sort of document like BB 101, which was quite prescriptive. So I kind of, if I had my client hat on, I definitely want something like this if it improved the design of the school and reduced the overheating. But I would be wary of just saying, oh yeah, just use these sort of various programs and then sort of transfer the data through the weather files. It would sort of, as a modeler, I know the mistakes that sort of multi-step processes like this can have. And also I'd be most interested in is there any sort of, clients always look for shortcuts and so on. So if there is something being sort of updated in AM11, it would be good to sort of almost have a, and these are the usual things that result from this modeling. So things like people like architects and landscape architects can sort of factor in that they'll need to maybe increase more green space in front of their schools, and that's going to be a natural result of it. People like to have little sort of, things like that. Otherwise, you get into the scenario that I remember happened in 2006 when you got the first EPCs appearing, where everyone tore their hair out because they had to put in heat pumps. Now I know that this sounds strange, but unless you sort of signpost things, people sometimes react poorly against it because they've got their own constraints and so on.
Great. Kevin, you got something to say?
Yeah, I mean, apart from just echoing what Alex was saying there, really, I'm thoroughly agreeing with the need for, or the desirability of having more accurate localized weather data. As somebody who works on models day in, day out and have done for 20 odd years, and works on a lot of other people's models and other people's jobs that have been taken to a certain stage, I could see the chaos forming when you try and duplicate somebody else's results that they put forward on a job so far to match up with whatever assumptions they've made on a weather file that you don't necessarily know of. You see what I mean? For example, I can look at the Part L report now and see that somebody has used a given weather file. If somebody produced a Part L report with some hybrid weather file which was cobbled together to an unknown method of mine, then I would have great difficulty in justifying whatever design decisions were made on the back of a report that somebody else had done, which wouldn't necessarily be able to correlate with one that I'd done. Does that all make sense?
Yep. So another point in the chat from RB now, who's RB? Richard Bowen. The other challenge is trees come and go and they can die or whatever. I had an associated point on this. When I was in India, I noticed that everybody used to irrigate the ground before early morning, and that helped to evapotranspiration, even if there weren't any trees in the ground. So I do think if you water the ground and water the plants, it would have a bigger effect than if you let them dry out, and then they wouldn't be very effective at evapotranspiration as they all closed down as they were dying, you see. So you do have to have a good maintenance of these plants, and the more you water them, the more they will evapotranspirate, I guess. So the more they will actually cool. So a lot of this does depend on really good maintenance if you're going to have rain gardens, and then should we have automatic irrigation of some of these? Because on a roof, I've seen a very lovely roof, but it had automatic irrigation, and that was why it was very lovely. If they hadn't had that, they would have probably all died, the grasses up there, or given less effect. So, how complicated are we going to make our facades is the question. What I would like to do is bring it back. Come back,
sorry.
yeah.
Just quickly, just some quick experience that I've had. I had exactly what Richard had, where a green roof turned brown because it was forgotten to be watered. And I would be, as a client, I would definitely not want that roof to be part of the performance of the building, if you see what I mean, because I just would assume that every few years someone would forget to water it. And similarly, a question to Yasmin, if you can answer it very quickly. I had a fascinating daylight study in a very dense urban area with a sort of new primary school, six classroom extension, and they were looking at daylighting, and I had to get the daylighting to a certain account. And there was on the east side of it, there was a row of trees, and they were trees which lost all their leaves in winter. Does the modeling take that? Does the external modeling software? Do you really have better data now? Because I remember looking at all the sort of BISRIA guides, and there was just nothing out there for how do you model a tree? And there was almost, how do you deal with the fact that trees grow? And it just sounds like maddeningly complex to model. Like, you planted a few Christmas trees, and suddenly 5 years later, you've got this thing which blocks out the sun.
Yeah, well, it is very complicated for me to understand as well. That's why the model has these things built inside it. So I tried to understand trees. It was like a very complicated algorithm of leaves and everything all together. And we see it as like blocks, like if it's Minecraft or Lego, but inside it, everything is considered. And yeah, trees are deciduous. There are a lot of deciduous trees, and it said that how much leaves are remained on tree each month. For example, 70%, 60%. Yes. So all these things are considered, and exactly, wow, I don't know how, but they did that.
Things have got better then. No,
Yeah.
I just really struggled in IES to model those trees for the daylighting study. It was like I had to take wild assumptions, which I wasn't comfortable with in the end. It was all accepted, but if you're looking at local landscaping and how that affects the building, I think one of the most strongest questions you have is how it feels like quite a burden to put on the client. What happens if the client doesn't want the trees and gets rid of them? And so does that suddenly make the building fail? I don't know a single client who would accept that, who would go, what, those trees stop my building overheating and I can't get rid of them? Well, make a better building is what I would say. Sorry, I know maybe that's not the answer the sort of this forum would like, but I know as a client, I would certainly, if I was designing a school for the next 60 years, the last thing I would want to do is rely on a bunch of trees to cool the classrooms, because I know what kids are like.
Yeah, but the benefits of green infrastructure is not just for it's cooling. It's a whole thing with the
No, I accept that.
Yeah, that's why we need the guidelines to so clients have to follow them.
But there is a sensible point there as well. Should we be relaxing our guidelines because we've got trees? I'm not sure we should. Already we're experiencing overheating with the BB 101 weather files that we've specified, which are 2050, 2080 ones. And on the south elevation, it's still overheating. So maybe we can modify some of those effects with these external measures. But perhaps we need to also increase our requirements on the basic measures as well, because like Alex is saying, you shouldn't rely on that tree to be there forevermore, perhaps. And it'll take 20 years to grow anyway.
Yeah.
This is a very fast growing sort of vegetation. So I don't really know. I was wanting to bring it back a little bit away from green infrastructure to what should we do with our basic guidelines? At the moment, are they inadequate? Because we've relaxed from 3 criteria we originally had in BB 101 to a single criteria now, and we don't require the heat waves to be part of the compliance. And should we reinstate that heat wave criterion somehow? Not necessarily in the way that we had it before for the single day, because I think criteria 2 was just 1 day, and even that day is not during the occupied term sometimes.
I mean, I can speak to experience that I had in a local authority very recently, if you'd like, and how we handled overheating, and then sort of lead to and some advice on that. But I don't want to take over the meeting.
Or maybe you can share that document as well with the group.
It's
some
just,
people
I
on
mean,
the group.
I haven't written it yet. I've just changed jobs as well to look at healthcare, so it's not. I wanted to sort of join to
that would be
give
worth
some of
having
my...
a presentation on, if you like. I think if you come to a consensus on that.
Okay, I mean, I could think about that. Anyway, so I'll let people continue.
Alan, do you want to comment on that?
Yeah, I agree that the criteria at the moment are probably too relaxed and probably should go back to the TM52. But a very simple solution to a lot of overheating is the use of ceiling fans, which we've talked about before. And certainly it helps deal with the future weather files tremendously. But another kind of general weakness is the way air movement is considered typically. So when you do a TM52 calculation, all it does is look at operative temperature. And the problem with that is, well, there's two issues. One is if your air temperature and your radiant temperature is the same, it doesn't matter whether your air velocity is 0.1 or 10 meters a second, you end up with the same number. So it's not actually accounting for the cooling benefit from the air movement itself. And the other thing is that when you look at something like IES modeling, the velocities that it generates are very low because it's looking at the total volume of the room with the air coming into it. But if you look at CFD and see where the air is actually moving, well, certainly beside the window and in the occupied zone, you got greater velocity than the average that IES would predict. So if you took that into account, you're actually getting a higher level of comfort than the modeling is necessarily suggesting.
I think this is coming around to the ceiling fan guidance that Chris Twin is working on, and we're looking for contributions. If anyone's got any data on actual, benefits of ceiling fans and calculation methods, because at the moment, CIBSE calculations don't really take it into account properly. It's a big issue, I think, Alan, and that's a benefit that's not taken advantage of then in the designs. People don't use that.
Well, it's a huge issue because recently I had various discussions with consultants who are being employed by contractors, and they're simply running the TM52 calculation and adjusting the air velocity in relation to operative temperature, but they're ignoring the kind of the TM52 equation, which properly accounts for the increased velocity. And they just kept saying that the building was failing. And it took about a month to get them to factor in the additional equation to get that extra comfort levels. So
and that would change the way people design, wouldn't it? Because they would then move towards cross vent, probably see the benefits of that, and also ceiling fans.
Definitely, yeah.
Malcolm, have you come back on that?
Yeah, can I just clarify something on ceiling fans? Primary benefit is for thermal comfort for people. A secondary benefit is perhaps a level of sort of cooling of surfaces, but I suspect it's an order of magnitude lower because implicit in TM52 and so on with adaptive comfort, the equations are based on large studies of thermal comfort in people, and they don't. I think the feeling is that the ceiling fans aren't captured by thermal comfort standards at the moment properly. There has been work done in certain countries looking at this, but certainly what we work with in industry in the UK at the moment it doesn't take into account. What you'd need to do would be to look at thermal comfort studies that have looked at people experiencing ceiling fans as part of that, an integral part of that study. I think what we're trying to do, it sounds like in the discussion as an industry, we're trying to process thermal comfort studies and contrive something, but it really is the benefit is for the comfort you get from increased air velocity on your skin. You get increased evaporation, hopefully, and so on. The air movement has a thermal comfort benefit. Say the benefit from cooling the actual building itself, I suspect is secondary, because you remember with, okay, you'll get a small amount of air, turbulence induced by that, but that dissipates quite quickly, and that will probably never, most air will never leave the space that's been in contact with the both the ceiling fan and the surrounding surfaces.
Yeah, you do need an offset to allow for the thermal comfort factor. It can't just be a building.
Yeah, but the point is, it's the benefit of ceiling fans that at the moment we're struggling to sort of take account of in the sort of simulations we're doing, is because how that benefit affects thermal comfort hasn't been properly addressed within the original standards. So I think it's something we need to look at perhaps in more detail about what those standards are saying about how it's not. And we do need to keep in mind that IES and TAS and all these other programs, or Design Builder, they're bulk models, they're bulk airflow models, they're not CFD. And all of these things we try and do they're sort of fudge factors. So just be careful about claiming some benefit that isn't properly justified, because a lot of things we do are to try and meet some regulation or standard, and we have to do it in a way as an industry that is uniform. I mean, it came up in discussion just now, didn't it, about not modifying weather tapes because it allows for gaming, doesn't it, or just pure mistakes.
I'm always beginning to think we need to go beyond modelling here.
It does. I mean, it's just, you have to take the starting point. If you look in the 2015 edition of M11, the starting point for the modelling is the thermal comfort standard you want to work to. And whether that's a heat balance model, the old Fangers model, or it's adaptive comfort, select your comfort, your standard of choice, and that's how you design your building. And that sort of follows through then into the modelling you try and do to try and demonstrate that, which is still an approximation. Because again, with thermal comfort standards, they're based on studies of large groups of people. You're not predicting the thermal response of a single individual with these things. So and the other thing with thermal comfort, there'll be a certain number of percentage of people are not comfortable whatever conditions you provide. That's been shown quite commonly. So you're never going to satisfy 100% of the people in the space, however well you design the building.
I agree.
Sorry, I've had a small rant there. So.
No, you're spot on. One point I would make, though, in terms of the impact that ceiling fans have on surface temperature, which I think is quite important, is for your night purge. So one of the problems with the use of MVHR to cool at nighttime is that the volumes are relatively low, and when the cooler outside air is brought into the classroom, it tends to just drop down to floor level.
So better mixing, you're saying, and therefore actually what you're saying then is that you're actually getting more closely matches what the simulation models are doing in the first place by having bulk airflow and fully mixed conditions in the space. Yeah.
Exactly. So you reverse your ceiling fans, you can pull the cool air back up onto the soffit.
Yeah, sorry, that's a good point you made there, actually.
There's a few points more in the chat that I think quite interesting, actually. So Joe Jack says, I found that a tree is easy to maintain than most BMS. That was quite a good one. Peter Hazard says, is there not a case already to have some sort of legitimate correction factor? For instance, tarmac +3, grass 0, trees and shrubs -3. So that would be an idea. And then for Welsh schools, we don't allow any relaxations to TM52. It needs to be complied with fully. But I still think that's a very limited thing, because criterion 2 is 1 day in TM52. I do think that is not appropriate to schools, really, or maybe only a lot of other buildings too. Paul Vorster says, open question, does anybody have experience with ceiling fans in practice? How robust are they? Prone to vandalism? ? And presumably not acceptable in SEND settings. Well, actually, we have put them in a school, and they loved them, and they put more in, and there wasn't any vandalism. And we have used them in SEND, but as wall fans rather than as ceiling fans in that particular case. So they can be used in SEND. It depends on the school and what they'll accept, of course. the ones that the ceiling fans were the rotating ones that were out of height but had a guard on them. I remember those well on an AD88. I can't remember actually. Quite a severe SEND anyway setting.
I would add that they're used all over Europe as well.
Yeah, I do think the proof's in the pudding a bit. I mean, Australia, they're going up to. I heard they deal with 45 degrees without any aircon with ceiling fans. Now, they must be doing something. I don't think they put them in for no reason. I just think our modelling doesn't really allow for it that well. So ceiling fans were installed, Peter says, in some rooms at West Coventry Academy, handed over in August. Very big in USA also. So although we can't model them maybe properly, or can we is a question, I think that we can get some way along to that, can't we?
Well, I would say that the equation in TM52, which is based on field surveys, which allows you to adjust the comfort temperature, it gives similar level of results that you would expect from looking at the ASHRAE guidance, and equally just put a fan on and see how effective they are, because they are very effective. And
you dug out the standard effective temperature from Australia, I remember.
That's right. Yeah.
So there is some effect they worked out on that. So I think we'll get there with that ceiling fans study group within the NatVent group to get further along this path. Joe, Jack, you got
Yeah,
something?
thanks, Richard. It's a really interesting discussion. I unfortunately had to drop out and I missed bits of it. So if this is all repeating stuff, just tell me to shut up. But I think the interesting thing here is I think there's kind of three bits for this. One is, do we actually even need to model it if we know it improves it? I mean, it could just be wasting time. If we know it's going to make a bit of an improvement, why bother? Secondly, do we think we really need them in buildings and schools? Can we design them out in the first instance? And is this really more of a kind of retrofit aspect? And again, if we're looking at retrofit, and I think that is where the big risk is. This is where most of our building stock is going to be. Mm-hmm. These are the ones that are going to be exposed to this risk. So maybe we just,
try it out.
Just try it out and get them in there. And I think it's going to be quicker.
I think pilots would be great.
And then we'll have that measured data. We can set up comfort sensors. We can ask the occupants whether it's fine, and then we can skip all the kind of concerns about climate files and and comfort bands, because we can just ask them.
On trees, I think there's other reasons to put them in. Is the reason why I think people are already skipping the calculation and going for the green infrastructure. So I think, we are already there in a way on that. We have skipped quite a bit of the modelling. It's just that we're still on our guidelines. We don't require trees, and we don't. So the base guidelines, I think, still are probably inadequate at the moment. We need to. This is where Alex, come in, Alex, and tell us what you
just
concluded from your study.
Alex,
but yeah,
just quickly.
Carry on.
Sorry, Alex.
Sorry, go on, Joe.
Go on really quick. I was just going to say, I think trees are far less understood than ceiling fans. I think that's the key thing to note. And I think fans is a kind of an easier one to do, just retrofit, but trees is slightly more complex. Sorry, Alex, go on.
Yeah. No. I would caution against not paying consultants to do modelling, because you want to spread the good how to think about buildings in the round through the industry. And I hate to say this, but the way to do that is to force everyone to do a bit of modelling to see the effect of it. The key results from the sort of place like this, because BD 101 was transformational in school design. It led to all the schools that I know having 4-meter ceilings, 3 meters in the corridor, and 4 meters in the classrooms with a bulkhead, MVHR.
Where are these schools, Alex? I've not seen anything with above a 2.3 meter ceiling for ages.
Yeah.
Which schools are you talking about?
The new passive house ones in Scotland.
Ah, right.
And one of the more interesting I've got to remember that London has bigger heat waves than Scotland. So, hey, you're seeing the effect of using different climate weather files, which goes back to our caution. consultants should be forced to do an array of tests with a local weather file that is standardized very comprehensively and report that back to the client. And then from that report, there should be a clear line of why we've designed the school the way we have. I would caution very much against any rules of thumb, because like Shetland's got really different weather from Cornwall and London. And this school design guides are used, throughout the UK. Where there isn't a Scottish guides, of course, deference is given to English guides. And so on. So, yeah, that's the approach that I would like to see. And I'm very new here, so I'm not. But I do have a client's perspective, which I think is always very useful. And I know consultants like to get paid to do simulations, and consultants like to get justifications for what. Like when you're asked, should I have this new bit of software which costs £5,000? If there is a fee at the end of it, every single consultancy goes, yeah, all right. But if there's no fee at the end of it, there's always well, why should we train you in something that we're not going to get paid to do? So if you want all these new, and I'm really excited by all these sort of ceiling fans and external sort of the local weather file things, if that was packaged up in a way that could be an easy scope, saying, oh yeah, do a TM52 or whatever, that would be brilliant for everyone involved, both for spreading the knowledge and getting everyone to learn all this new stuff. And then in 2030, having an updated AM11 when, this one. Anyway, I've spoken enough.
Alan, you're next.
Yeah, I think it's important to be able to quantify the benefit of the ceiling fans when you're just comparing it with, say, cross-vent, for example. And certainly the modelling that we've looked at shows that with ceiling fans, you can comply with the 2080 weather files with single-sided ventilation. You don't need cross-vent to do it. And the point to make is that cross-vent is an expensive addition to a school. It potentially increases the embodied carbon with all the attenuators and openings through the spaces and the rebar, etc., that goes with that. And the money you save on your cross vent certainly pays for your fans without a doubt, but it probably pays for a geothermal system as well. So you could actually potentially have some kind of reverse cycle heat pump pulling heat out of the classrooms. So you're getting an absolute win-win out of the whole process. So being able to quantify these different options is really important.
Joe?
No, I I tend to agree. I think quantifying these things, I just think that I don't think we should be designing schools that require fans in the first instance. I think we should be aiming to design them out. But I think we should have the flexibility to include them. I think my point is that from my point of view, I just think that the schools that are really going to benefit from this are existing schools. And I think the evidence base is not modelling, because if you've got an existing school, just sling it in. How much is a ceiling fan? A couple £100, 350 quid to get it wired in, maybe, if you're depending on your person. You could blow through that in no time in terms of modelling. I think it'd be great. And there's your kind of evidence base. But I do agree. I think that there's a complex supply chain around delivering schools, and consultants need to be part of that. So no, I agree. It's just let's do it and try it out. I'd be much happier with that. I mean, obviously in a low risk place.
If you find any places to do it, Joe, let us know. I've been looking for a long time. We found one so far, and I've tried to get it. I haven't managed to find another one yet. But
obviously, anyway. Richard, none of our schools overheat, so I wouldn't know. But I'm sure I can find some.
None of yours? Oh, I thought you meant none of the existing ones. Plenty of existing ones. Anyway.
Yeah, definitely. I'll have a rummage so I can find.
Malcolm.
Yeah, thanks, Joe, because you've led on to my next question for Richard and Azada, I think. How's the evidence base these days for overheating in reality for new schools and for existing schools? I mean, are you still having lots of reports of overheating in either sector, or has it pretty much been solved? I mean,
how
are things?
Quite often we're getting overheating new buildings. Because of our criteria, I believe, but just being criteria 1 now, and having to report on 2 and 3 and having a strategy to deal with it, we are experiencing overheating. And I think the reason is because it doesn't allow for the heating up of the air through the facade. is my hunch, and over the roof before it gets to the inlet. So we have cases where the facade inlet, if you're using room ventilators or vents into a room that are on the facade, that facade can be, the grills on that facade can be 50 degrees, you know, in summer on the south. So we get local overheating on the south because we have no shading, and the modelling doesn't take account of these effects or the way the modelling is used. I'm told IES can take into account the heating up of the grills, but I don't think it's normally used like that. I think normally people take the average ambient outdoor air temperature as the supply temperature.
What I mean, I mean, I can almost anticipate the answer to this, but why not just specify they should be painted white? You know,
It doesn't make that
got,
much difference. They still heat up. You know, I've got silver
even
ones that are very hot as well. You know, they're
not
quite
silver,
reflective.
but yeah, but
A
I mean,
white facade, you can measure a white facade is very hot as well in summer. Acrylic rendered white facade, 40 degrees easy.
What would a darker colour be? What would that get up to?
Well, that would be 30 degrees in winter almost, as soon as the sun comes out. But so, you know, I take a thermometer and measure them. It's quite surprising. I did it one day and I was shocked in October. And people saying we can't teach in this classroom. And we were saying, oh, it meets our weather file. But they're saying, well, I don't care. I can't teach in it. It's a top floor on the south. So, you know, I don't know. I think this thing's wrong with our models. The IES model doesn't, or it's not being used correctly. Perhaps that's what I should say. Alan, do you have a take on that?
I'd be interested to know if you've drawn conclusions from these investigations you've done. So I think you've done quite a lot of work over the past few years, haven't you, on looking at this and what's going on?
It's not proper work. This is the problem. It's just me going out with a thermometer, you know, radiant. It's not. It needs work. I think it does need work. It needs people to go back in summer and find out what's going on in a classroom. You know, a bit of POE on a hot day. Just go and measure it and see if your model predicted anything near what's actually happening.
So, but from what you're saying, it sounds like the design solutions are being come up that meet the criteria. In practice, the local effects are sometimes causing overheating. Then
especially if you have asphalt in front of the building, like people have said. And that isn't taken account of in the software calculation properly. So you know, Kew Garden School, where we did the pilot, it did have asphalt and then a mugger. And I think Yasman has shown that muggers and artificial grass heat up even more than asphalt. So, you know, we've got a problem when we don't model those effects routinely somehow. Is there a way of doing it?
I mean, those ones are outside the building, aren't they?
Yeah, I agree. Yeah. And also the roof, you know, we had some roof inlet room units, and they were shown to have in practice, the contractor measured them, and it's 4 degrees hotter than he thought it would be coming in the supply air, because it's a black roof. Any more comments, Helen? No, sorry, Alex is next. Alex Melika. Alex, are you there? Or let's move on to Alan.
Yeah, like the Kew Garden School, that's a modern school.
Yeah.
It complied with BB 101, etc. It's just that it was the summer where it was just horrendously hot, which meant that it was overheating. The weather was just too hot for it.
But it's not only that 1 year, Alan, because they've installed the ceiling fans in the trial rooms. They, at their own expense, put them in all the other rooms. And now they want canopies as well on that facade. Yeah. Because they think it's just not comfortable enough.
When we were there looking at the ceiling fans, so that was very interesting, was when we went from one room to another, and the teacher of that particular classroom had plants all over the windowsill, all over the shelves, and windows were closed. Everything was identical to the other room. But I think anybody who walked into that room suddenly felt cooler because of the impact of the plants themselves. Just one other point, when we were looking at performance of existing schools in relation to what we're going to look at for Welsh Government, their standards. One school that Peter went to, which was a passive house school, it showed that there was indications of overheating on the southern facade. So passive house obviously is trying to encourage more solar gain from the southern facade, but the indications were that it was causing difficulty, which I thought was interesting.
Paul?
Yeah, Richard, do we know whether the new schools being delivered under BB1, whether they overheat because the modelling wasn't robust or whether the model is wrong? I'm trying to distinguish where we end up with bad school design because the modelling wasn't robust.
Something I couldn't really tell you.
Because I have to be honest, in our experience, and I wouldn't mind Alan coming on this as well, or Peter from Candle. I mean, there's a group of people I know in the industry that do robust modeling. We don't tend to see overheating in the schools we design. But then I come across designs from others that people try to convince me, in the absence of thermal mass, for example, in the south of England or London, that it complies with the 2080 weather file, and go, there's no way if you did robust modeling that you will get that answer. So that's what I'm trying to get to. I don't want to, what I'm trying to say
well,
is,
it could well be that.
It could be, but we shouldn't be throwing a baby with the bathwater. If the problem is lack of robust modeling, then maybe there needs to be guidance in BB 101 that stipulates certain parameters that needs to be within your model, where we know people can fudge it. I know thermal mass is an important one, where people model a thermally heavy building when it's definitely not. So I think before we completely try to reinvent or change how we model, but let's establish whether the problem is in the modeling or the building design. From what I've seen is when you conduct robust overheating modeling using, robust assumptions, you end up with a very good school design that doesn't overheat. I just want to get other people's input on this.
Well, I agree with you. My view is that regardless what a model tells you, if the design doesn't look like it's a good design, then it probably isn't, regardless what the modeling is saying. And I would say that the skills in the industry is very mixed. So some people would do very robust modeling, others will not really know what they're doing, and they'll get a result. And if they're happy with it, computer says yes, and that's the answer.
That's been my experience, Richard, and I'm glad to hear Alan's similar. So I think the tools we have is appropriate, and I think somebody said, remember, this is an overheating assessment tool. It's not going to get rid of all overheating in all scenarios. That's not what we're doing. But we can end up with schools that are comfortable in most scenarios for most people if the modeling is robust, which is what I think we can do. We have the tools to do that. But so maybe to prevent misuse of the modeling tool is maybe be more prescriptive on certain assumptions that needs to be made in BB 101. So if you have, like wind speeds, thermal mass, I think is a key one. I've seen things like that. We need to say, well, if you're putting a volumetric school in, which is made from SFS and who knows what, paper mache, then you can't be using a thermal mass value of 230, something to that extent. It's just be more prescriptive,
so maybe it's
and that's something
of
the
the
TA can
models.
check.
They need more checking of these models, perhaps.
Well,
that's what.
Well, no, it's impossible for a TA to check. But if you declare that within your overheating assessment, I've read so many overheating assessments where those key parameters, which I know have a fundamental impact on the outcome, are not even listed as assumptions. So how is it possible for the TA to check that? The TA's job should not be to check the outcome, the output. It's just to check the input. So that should be clearly listed in any overheating assessment report.
That's very
and then
good
the
suggestion.
outputs make more sense.
Well,
I see so many TM overheating assessments tells you all the rooms passed. Okay, but what assumptions have you made within your model to get to that point? And that's the key missing.
So we need a list of the inputs.
Well, this is something I absolutely believe in. Like, if you take it that the contractors have all produced their standardized designs, which they want to roll out across all the schools they produce, and you could have it that for the first one that they're going to build, that they go through robust modeling and they identify the key parameters that are delivering that standard. And then after that, for subsequent schools, you just have a checklist to make sure that they have the same key parameters, not wasting time modeling the same building over and over again. That's just a waste of money.
I agree with that. I think we should be moving towards every one of the big framework contractors have a standard design. You should be able to do a set of modeling on the standard design, get that approved by the DFE or TA team, and then let them roll out. You don't have to do it on every job. You'll save an awful amount of money on fees, time, all sorts of things. We need to move towards time proving.
And maybe we should have default values you have to use. If you don't use them, do you know what I mean?
Alan and I work for the same people. They all have their own school design, isn't typical school design, and it's no coincidence these things look very similar.
Yeah.
So
but we are getting the volumetric people who are claiming that some of these things pass when they obviously wouldn't pass.
Yeah,
that's happened.
Yes, I'm very aware of that. I'm very frustrated by that because we lose work to them.
Yeah. So thanks for that. Dora, are you coming in on this?
Hi, yeah, I totally agree about the thermal mass. We see it more and more not being used in schools because it's clashing with many design, because we don't have we need the ceiling voids for equipment and things like that. But also another question is how we test the overheating post-occupancy, because you can test TM52 and a model might pass through DSY1 or even DSY2 and 3, but if you check the absolute temperatures, like dry resultant temperature in the space, it could still be 30 degrees, which might not be acceptable for lots of people. So it is adaptive thermal comfort, but under which criteria are we testing overheating post-occupancy? Is it the comments of the people? Also, we're testing schools throughout the summer period as a worst case scenario, and we should check worst case scenarios and all the potentials as consultants. But then again, lots of there is a period on summer that schools are not occupied. Another challenge is also when you're designing a school that's not a typical school and has different types of uses and activities, we must adjust the inputs of the model to a real life scenario and not to the defaults that maybe BB 101 is prescribing to give an accurate design and a good design.
Thank you for that. We do need more work on the post-occupancy methodologies, I think. And maybe that isn't by DFE, it could be by research people. We've only got a couple of minutes left, I believe. What time were we finishing? 5, yes, that's right. So, Alex, you still got your hand up. Are you still there? Do you want to say something? No, it might be a legacy hand. Well, I think it's been quite useful today. I don't really know. Andre wants to come in. Ottenbracht. Andrew.
Yeah, just remember to switch my camera and my voice on. So I was involved with, and there might be a few people online from Hampshire County Council. So I was involved in a lot of school work, but not new build. But recently in my new role and in a different company, we've had a couple of thermal models done by full CIBSE assessors, and the guy that's done it, because you were talking about the criteria and what they've used and showing what they've used, and this was a 3 criteria arrangement a few years ago for a warehouse, and he also did some modelling for a private school to show that sash windows would work a lot better than sliding windows. But just to say that I've just checked one of his reports, and do not, if you are a CIBSE accredited assessor and you produce thermal modelling reports, do you not have to report in a certain way? Because certainly that report that this person had produced has all the information that you've been talking about recently about the criterias, the materials that have been used, how you prove it, what things work, didn't work, that sort of thing. And this guy, in my view, and I talked to him a lot about how we could manage the natural ventilation, high level windows, how many windows we needed, automatic opening louvers, things like that. That was all encompassed within these models. I might be on the wrong track, but he did show all that information. Is that not normal then for if you have a proper CIBSE approved sort of ratified modeler?
Anybody want to comment on that? I wouldn't like to say.
Yeah, no, there is no prescribed standards for anything like that.
Oh, okay. Oh,
So
I
you're in
assumed
the
that
hands
his
of
was
the-
a standard because it was very, very thorough. I understood it. You know,
Yeah.
I think if someone's done robust modeling, then they want to capture all that.
Yeah.
To show what the basis of the calculation is, because it's about overheating risk, and that means it will overheat. So you want to make sure that you said, first of all, here's the basis for the design. So if someone changes that, you want that captured as well. And then if it's overheating, you say, well, it's overheating in line with what we had predicted. So yes, it happens to be hot today because it's a very hot day. Sorry.
Yeah, no, you definitely said all that, and we put in measures, and we put additional measures like blanking out some of the roof lights or changing the G values, and obviously that's all part of modelling. I'm not teaching anyone; they know that. I'm sure I don't know a lot about modelling, but I do know a lot more now than I used to know. But we do those scenarios, and we came to a compromise with the client. You know, we could meet it if we did all these measures, but if we didn't do that, we'd get very close. Obviously, it wasn't a school for the first one, it was a big warehouse, but the school did accept another model for the second one. But they took away the ceilings, they used a thermal mass, they put some, they opened up some back windows that were there.
It all sounds great, Andrew.
I'm talking about examples. This is
That's
not
a
what
good
you're
example.
talking about, but it's useful. Cross ventilation, obviously, but without fans. So we showed it with fans, but actually the fans did make a big difference in that scenario. Or sort of not fans in the room, but extract fans, say, or something like that. We just showed that thermal mass, natural cross ventilation with sash windows, and the G value of the window being changed. So new windows with a very high G value on a south-facing single-sided classroom could perform very well compared to what they had before.
Excellent.
And he showed all that in the report, which was just what you want, really.
Is that Hampshire, you say?
It wasn't Hampshire, no.
Where was it?
So the school was in Southampton, but it's for a private school.
Great.
And we were asked as a consultant to look at that.
Great. So Alan, last word to Malcolm, and then we'll close the meeting, I think. Malcolm?
Yeah, I just wanted to clarify that the CIBSE accredited energy assessors who can do the modelling, it's for producing energy performance certificates for non-domestic buildings, and there's three levels 3, 4, 5. And for what we're talking about, you probably want to find a level 5 energy assessor. That itself isn't to do with overheating calculations, but they should have the right mindset about reporting what they're doing, because they have to do that to the rest of the design team anyway, to explain, as Alan was saying just now, that you should be communicating as a modeler with the rest of the design team to say what the basis of your calculations are, because if you don't, there'll be other in reality it won't match your assumptions. So there isn't a CIBSE scheme for overheating calculations, a sort of an accreditation scheme for modelers at the moment, but I think the someone with a sort of level 5 accredited energy modelling will be able to handle this quite well, I should think.
That's really useful information, Malcolm. Last word to Kevin, and that is the last word.
Yeah, promises the last word. Just a quick one. It was only to say that on top of the LCA accreditation, there's also the low carbon consultancy for building simulation accreditation, which is a separate thing.
Oh, okay. Who runs that? Is that the Building Simulation Group, or is it?
No, it's a CIBSE accreditation.
CIBSE.
It comes under the same sort of wing as the LCA accreditation, but there are a couple of different categories. There's, I mean, I've got the LCC for design and building simulation, which are two separate ones.
Right.
Now, I can't imagine there'd be too many level 5 assessors who haven't also got those qualifications, but they are a separate branch which deals specifically in low carbon design and the simulation of buildings. So, yeah.
Great, thanks for
that was it.
Great. Well, thanks everyone. It's been a very interesting meeting. I hope it's been useful, and we'll keep in touch. Thanks very much.
Cheers all.
Thank you.
Thank you very much. Cheers, guys.
Cheers.
Cheers.